Hello. Our today's topic is of new chapter is benzene and its compound. What is benzene? Actually, benzene is called as an aromatic hydrocarbon. This aromatic name comes from the word aroma. Aroma, which means fragrance or smell. Peculiar type of smell is present in the compound due to the benzene. When the benzene was discovered, it was observed that due to the benzene molecule, a peculiar type of fragrance is present in hydrocarbon. That's why this is called as an aromatic hydrocarbon, and generally the compounds are called as arenes. This is a functional group also, which represents particularly benzene. Now, for benzene, actually benzene is 6-membered carbon ring having alternate single and double bond. That can be represented just like this. That can be represented initially just like this. Alternate single and double bond. That's why if such type of the situation, this alternate single and double bond is called as a conjugation. This 6-membered carbon ring, if a conjugation just like this, then that molecule will be called as a benzene. Now, this benzene molecule doesn't follow the general formula of alkanes, alkenes or alkynes. Never. We know that the general formula of alkanes, alkenes and alkynes are CnH2n plus 2. This is for alkane. CnH2n for alkenes and CnH2n minus 2 for alkynes. But benzene is not following any general formula. For example, alkyne. If we put carbon 6, then how much hydrogen should be there according to the alkenes? According to the alkenes, it should have 10 hydrogen atoms. But the vapor density formula, which is applied to find out the molecular mass of the benzene ring, that indicate that molecular mass of benzene is 78. And this indicates if 6 carbons are there, means 12 multiplied by 6, it will come 72. Here, how much left? Only the difference is left of 6. If we add 6 more, then we will get 78. So, scientist reaches the conclusion that these 6 are only the hydrogen. It means that the formula of benzene is C6H6. This is the formula. And this is the formula possible only when benzene has a cyclic structure with 6 carbon atom ring having alternate single and double bond. Then automatically each carbon atom valency will be satisfied and each carbon atom will have only one hydrogen with it. So this will become the structure of benzene. Now, according to the formula of alkyne, general formula, there should be a 10 hydrogen, but how many hydrogen are present? Only 6. It means that this benzene ring is a very short of hydrogen. It means that high degree unsaturation is there. High degree unsaturation is there in benzene. Then, this cyclic structure was given in 1865 by Kekulé. Kekulé is a scientist who proposed two structures which are called as resonating structure. The Kekulé structures are represented just like this. Thus, a single bond in this structure will be double bond in second, and the single bond in second will be double bond in the first one. So, both of these structures proposed by Kekulé was used for the benzene, and the actual benzene molecule is average of both of these. Average of both of these. Now, the resonating structure. What are the resonating structures? Those structures which show difference in the electron pairing arrangement scheme, those are called as a resonating structure. According to the rule, if a molecule has a large resonating structure, it will be maximum stable. Now, benzene has two resonating structures. Also, the X-ray analysis or X-ray studies prove that in alkene, carbon-carbon single bond is of 1.54 nanometer length, while in alkenes, the carbon-carbon double bond is 1.34 nanometers length. But in benzene, it is observed that carbon-carbon bond length is 1.39, which is in between these two, double and single. In between. That's why it was proposed that to mention these single and double bonds separately, as all the 6 carbon atoms are identical in chemical environment or in other vectors. That's why instead writing these 3 separate double bond with single, we use a circle in between the benzene ring, which indicates that all bonds are identical. Neither these are single and neither these are double covalent bond. That's why it is preferred now to put the circle inside the benzene ring rather to represent the single or double covalent bond. Now, according to the molecular orbital theory, if we observe as the double bond is present and unsaturation is there, in benzene molecule, the sp2 orbital hybridization is involved. According to the sp2 orbital hybridization, we know that if we consider the electronic configuration of carbon first. Now, carbon in its ground state is electronic configuration 1s2, 2s2 and 2p. X1, 2p, Y1 and 2p, Z0. But in excited state, it will become 1s2, 2s2, 2p, X1, and one electron will be shifted from 2s to 2p, Z, 1, 2p, Z. Now, one electron will be shifted from here to here and automatically carbon will become tetravalent. Now, in case of benzene, for the explanation of benzene structure, we assume that 1s and 2p orbital intermix together to give 3 hybrid orbitals, and each orbital will be called as sp2 hybrid orbital and can be represented just like this. These are three sp2, one carbon, then is next carbon, then is next carbon, then is next carbon, then is next carbon, Then is the next carbon. Now each carbon via this sigma bond formation this is sigma bond, 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 and this is sigma bond. How many sigma bonds are formed? 6 sigma bonds are formed between carbon-carbon by sp2-sp2 overlap. This is called as sp2-sp2 overlap. Now, rest of the sigma bonds are formed by 6 hydrogen atom overlapping with 1 s of hydrogen atom, making 6 sigma bonds more. It means that in benzene molecule there are 12 sigma bonds. This is also sigma bond, this is also sigma bond. All these are sigma bonds. Now, all these are hydrogen atoms which are attached with benzene. Now, what left? Now, only this unhybrid p orbital is present on each carbon, which is present at the right angle to each carbon atom. These are also 6 that can also be represented just like this on sidewise. If we put this as this skeleton structure of carbon atom, then 6 p orbitals are present just like this. Now, after formation of sigma bonds, these pi or this p orbital sidewise overlap with one another, making 3 pi bonds. Now, the upper loop will overlap with upper loop and lower loop will overlap with lower loop. It means that making this carbon skeleton as a sandwich, a common region above and below is developed, and all 6 electrons, each electron present in each carbon atom, will start revolving either above or either below the carbon skeleton, and this all 6 carbon atom formulate as pi electron system, which is called as delocalized pi electron system. Why? These electrons are called as delocalized because they revolve over entire molecule between the different bonds. That's why this is called as a delocalized system. Now, this pi electron delocalized system formulates a stretched sheath over benzene ring, and due to the revolution of all these electrons over the entire benzene ring, gave extra stability to the benzene ring. That's why benzene, in spite of the fact having a high degree unsaturation, still prefer to perform substitution reactions, which are the characteristic property of the saturated hydrocarbon. This is the reason why benzene give substitution reaction instead of addition reaction quite easily. The reason is that pi electron system revolve and provide extra stability to the benzene ring. I have explained about the benzene and its character. Please comment, like, share, subscribe my channel. In case of any problem, you can directly, you can send message, you can comments on my lectures and whole of the material provided. I thank you all.